All right, welcome everyone. Today is Wednesday, the 18th of September, 2024, and this is the Cluster API Carpenter Feature Group meeting. Um, Marco, if you want to, I'll make you co-host if you'd like to share. You can share screen. Um, there we go. I'll make Marco co-host. So anyways, this is the Carpenter Feature Group meeting. We are a sub-project at Kubernetes SIGs, and as such, we follow their meeting guidelines, which basically boils down to, please be kind to everyone, and if you want to talk, raise your hand. But there's only three of us, so I'm not gonna stand on ceremony for that. Okay, so I just had a couple items that I added to the agenda for today. Um, the first one being the current status of the repo migration, and everything's looking good. I've invited several folks to join as maintainers on the repo, and I think we've got a good mix of folks. I invited Marco. I also invited Scott from TerraSky and Mike from Adobe. Um, it seemed like we have a good mix of people who've been around since the beginning of kind of the design discussions and whatnot. But this would at least give us, I guess, more kind of coverage in case we need people who can help merge things and whatnot. I have also included the cluster API maintainers on the list there as well. So we have good backup coverage with the cluster API maintainers and the SIG Cluster Lifecycle maintainers as well. Um, so I think the only thing we're waiting on now is for I think it's the ContribX or maybe it's the infrastructure folks to kind of like take the next step on this and do the migration and everything. Um, I know Marco, you've got an open PR for joining the organization, but as far as I could tell, that wasn't a blocker for us getting this PR merge. So, or getting the issue kind of taken care of. So hopefully, I'm very hopeful that by the end of the month, we'll have it moved over. Potentially even like, this week or next week or something. So anyways, yeah, that's kind of where we're at with the repo. Did anybody have questions or comments about that before I move on? Okay. I will move on to my next topic, which is basically uh, what are some things to do, that we need to do. And I had I had taken an action item last time to update the feature group charter, but I did not get around to that yet. So I think it seems like it is worthwhile to keep these meetings going. Marco and I talked about it last time. I think we have enough things going on that there's probably some value to this meeting, at least to broadcast what's happening and kind of the current state of things. The next things that I would like to get done, or I would like us to do, I guess, as a group, is update the feature group charter, starting a draft of the KEP for cluster API to describe the enhancement of how we'll integrate, and then also create a Slack channel for the discussion of the provider. I think, probably we don't, having the Slack chatter once we get the repo migrated, I think will be important. But these could probably be taken care of over the next month or two. Leading up to KubeCon, we could have something kind of, I don't know, fun to talk about for people who are going to be at KubeCon. So I guess, yeah, any questions or comments about kind of the next steps that I'm proposing here? Cool. Thanks, Marco. Okay. So those are the main topics I wanted to talk about. I think like one other thing that I've been thinking about recently, and I'll just add a note into the agenda here, um, is kind of like alternate designs, focusing on kind of the API contracts, right? Uh, so recently I was doing some review work of the managed Kubernetes enhancement for cluster API, and looking at the way like machine pools and whatnot were kind of specced out in that. And there's this notion that in cluster API, if you can kind of like abide or meet the API contract for something like the infrastructure provider, then cluster API can be very pluggable in a sense for ways that the infrastructure, could be made. And I was thinking about this and I was wondering, like, um, in the case of like managed services, one of the recommendations is to create like your own API type that kind of wraps or stubs, the actual API type. So you could imagine if you normally have a machine pool in your provider's API, that you might have like a managed machine pool or something to cover the machines that are actually being brought in by a managed service. And so it made me wonder, like, there might be a totally alternate way to look at bringing Karpenter in to cluster API, and it would be very different than what we've done so far, but it might be a way to get the provider specific versions of Karpenter into cluster API. And that would be like, what if there were like a machine pool object or a machine deployment type object or something, that almost looked like the managed service API objects and wrapped some sort of interaction with cluster API. So, the notion here is that, or wrapped in interaction with Karpenter. So the notion is that you have some sort of like Karpenter machine pool, right? And it presents the contract to the core cluster API bits the way that it's expected to, meaning the API fields are where they're expected to be. But under the covers, the Karpenter machine pool or whatever could actually be managing the cluster using Karpenter. Um, I have a feeling there would obviously be some work that would need to be done to be able to reconcile like machines that are coming in from Karpenter. But I just thought it was like a kind of another way to look at this and kind of flip things around. Um, and one of the reasons I'm thinking about this is because I had been having discussions with some people about, you know, would it be nice to be able to use something like the EC2 fleet interface in finding the right instances and whatnot, right? And this is something that like the Karpenter AWS implementation uses the EC2 fleet interface to find instances in a much more efficient way. So the notion would be like, okay, right now cluster API uses the normal EC2 compute, interface to find instances, but it's not actually looking for different types of instances. It's just looking for the one you're asking for. So in a situation where Karpenter was managing the back end, we would have this kind of wrapper object that would just allow Karpenter to do what it wants to do, and it could go looking for, the type of instances you want using the EC2 fleet interface to do that. And then we would be responsible for kind of making the machine objects appear back into, the cluster so that you could see what had just happened, basically. Jeremy, I see you got your hand up, please.
Yeah, so going off your previous way of presenting this, where Karpenter would be looking at cluster API as the cloud provider, you'd basically be flipping that around. So cluster API is looking at Karpenter as the cloud provider.
Yeah, almost exactly. Like Karpenter is providing the contract of a cloud provider and is like making and managing the nodes for you. Um, I don't actually know if this would fully work or not, but it was like an idea that, was being tossed around as we were talking about different interfaces and different ways to do these things and whatnot. Um, so yeah, it would be a radical difference from what we've already created, but I think this is where we're at now. We need to look at like different kind of designs and understand different ways that this could be useful. And part of the reason for this is that one of the big issues we need to solve with the cluster API community coming up soon is how are we going to expose the pricing and cost information from a provider so that it could be used by a tool like Karpenter. And so, depending on what we decide as a community, this might have some bearing on us revisiting the core design of what Karpenter CAPI looks like. But I'm not doing any code or anything yet around this. I just kind of was thinking about it and speculating, and it occurred to me while reading some other enhancements. So I wanted to share it here just to kind of, see what other people thought and, just kind of socialize the idea a little bit.
I mean, kind of at first glance, it seems like it, or first thought, it would be a good way to do it, and in that it would be preserving kind of this very loosely coupled relationship that Kubernetes components have. right? Like if you back up and look at the cluster as a whole, and Carpenter, like right now, it's like Carpenter doesn't really know in many ways, Carpenter doesn't really know what's going on with scheduling until the scheduler has tried and says, I don't know what to do with this. And then Carpenter picks it up and takes that forward. And that's helped us with our migrations, because we basically have Carpenter and cluster autoscaler running at the same time. And this loose coupling of it is just, scheduler tosses it over, says, I don't know what to do with it. Someone picks it up and does something else. And then the scheduler says, oh, wow, there's compute here. And so doing this would kind of preserve that same relationship. Cluster API doesn't really need to know all the weird things that Carpenter does with regard to cost and interface with the cloud provider. It just needs to say, oh, there's new compute here. I'm happy with that. And it knows how to integrate that into whatever it's maintaining.
Right. Yeah, exactly. It would kind of be like letting Carpenter drive, but and cluster API would just become like, kind of the metadata slash passenger that goes with it. Now,
Yeah.
unfortunately, the downside is it kind of breaks some of the expectations from the cluster API side, which is that if I had, like, let's say I had a Carpenter machine pool object, right? Then the expectation would be that a user would not be able to manually kind of change the replica count on that thing because Carpenter is managing the replica count. And, to the point you were just making, you want Carpenter to be like auto provisioning things for you. So Carpenter is waiting for things not to be schedulable or to be pending, and then it does something. So it's a little bit of an inversion, on the user experience as well for
Mhm.
people.
And that could help out as well with future Carpenter development work, because AWS could add the ability to manually scale out a Carpenter node pool, because that is a feature that people want. It's something, it is kind of a gap um, with regard to being able to pre-scale stuff, which ideally you don't need it, but yes, you do need it a
Right.
lot of the time.
Right. Yeah.
Um, and also other, Carpenter features in there that could be added over time, such as, being aware of ODCRs and anything else that they're doing with, node overlay configurations or whatever.
I mean, yeah, exactly. So like this may be one of those things where it might be worthwhile to try and experiment around this. I don't know if my you know, I'll definitely try to figure out if there's like a way that we could kind of run an experiment to see if this is even possible. But I just thought it was like another idea that was worth discussing. And since I think we're now heavily into like the experimentation side of things, it seems like now's the time to kind of think about these, interactions and whatnot. Yeah, Marco, please.
Yeah, quickly question, like returning from the design, if you don't mind to refresh it. Are you requiring to the cloud provider a Carpenter implementation for each cloud provider that will be supported by Cluster API Carpenter provider? Do
I
we
would,
need
yeah, I would expect no in those. Like, okay, so the design that we currently have, right, is going to be maintained by Cluster API Carpenter maintainers, right? Like we have a very specific Cluster API implementation and it speaks to Cluster API. So that is definitely maintained by the Cluster API community. This other kind of model that I'm talking about, that I'm just speculating about, it would rely on having, you know, concrete implementations for the provider that you want to use it on, right? So like currently it would only work with like AWS and Azure, right? I would expect that the Carpenter communities that are maintaining the AWS and Azure providers currently would continue to maintain those. What the cluster API people would maintain would be whatever this mechanism is that allows you to have like some sort of API type that could wrap a Carpenter provider. And those API types might even need to live with like the cluster API providers, right? So imagine if cluster API provider AWS also included an API type that was called like Carpenter machine pool or something, right? So if I install Kappa, I now get access to the Carpenter machine pool object that I could use to allow Carpenter to like manage this thing. So like that would be maintained by the cluster API community, but I wouldn't expect the actual Karpenter implementation to be implemented by the cluster API community, or maintained, I should say.
Got it. Yeah, because my thinking about your thoughts was try to understand if you, for example, if Kappa using SC2 fleet, they will have their own engine to implement to provision effectively the nodes inside the cloud provider. Using
But
that implementation strategy, we could have more than one using SC2 fleet, using run instance, the regular run instance, and using outscaling group, for example. So
right.
three different engines of provisioning using different fleets management, I would say. Yeah,
Uh,
that's a good idea, and trying to understand.
Yeah, this is the most complicated part of this to me, which is like right now, cluster API, um, everything has to be defined in cluster API, the instance types you're making, everything, right? So even like the machine pool, the way it's implemented for AWS, if I remember correctly, is it uses ASGs on the back end, right? But it only uses ASGs with a single instance type, right? So it's a homogeneous group, ASG group or whatever, right? So something that Cluster API does not do right now is it does not have a way to collect or to represent uh, heterogeneous groups of machines as a single collection, right? And so Carpenter is going to be making all these different types of machines, but there's no like one way to look at it from the Cluster API side. So like even if we had a Cluster API controller for Kappa that could use EC2 Fleet, it still wouldn't be using it in the way that like Carpenter uses it, which is like, Carpenter just puts some constraints in there and says, show me what instances will match these constraints. Cluster API, even if it was using EC2 Fleet, it would still just be saying, well, find me this one instance type in this one zone, and like EC2 Fleet can find it instead. And that doesn't really offer you the benefits of like the Fleet interface, right? So like I think some of this too is that we need to keep pushing the discussion in the cluster API community around like, are we ever going to have some way to represent heterogeneous collections of machines that could be scaled by some interface on the cluster? Because that's going to need to be managed in a different way than what we're doing currently. I don't know who had their hand up first. Was it Marco or Jeremy? I'll just go. Marco put his hand down. So Jeremy, it's you.
Cool, thank you. In talking about this, and maybe this is getting into the weeds a little bit too much on implementation, but I recall you talking or mentioning in the past that there could be performance implications to the method that you have been trying, where Carpenter is calling cluster API and it's bubbling up through all of that. So with your thought to flip that on its head and go the other way, would that preserve Carpenter's performance or eliminate any concerns around performance on scaling and this kind of decision making?
Yeah, I mean, it would make things a lot clearer. Yeah, I think it would, because you'd be using the native performance. So like, you'd be using the native AWS Carpenter client. So like, yeah,
Mm-hmm.
I have a feeling that it would perform better because it would just be using a normal node pool to like look through AWS's inventory, right? It wouldn't be restricted by the cluster API objects telling it like what it can make or what it can't make. So yeah, I would expect that it would behave better and probably perform better in the short term, at least until like, the cluster API version had kind of filled up all the gaps. But this whole like EC2 fleet thing we're talking about kind of gets to the main point of it, right? Which is like, you know, if you were using a native AWS Carpenter, it could use the EC2 fleet interface to find machines in a much more efficient way than if I have to just search the cluster API objects, to see what's available. So yes, like I think it would behave better, um, but at the cost of probably losing the functionality of the cluster API side of things. So and again, these are all like trade-offs, right?
Yeah.
Well, like good discussion. I must have hit a nerve with that topic, so that's cool. Um, anything else people want to talk about, or other questions or topics people want to bring up? We got about 9 minutes left here.
And just one more comment on the performance front is
Yeah.
I am kind of sensitive in these discussions to, the prospect of having performance be worse on scaling, because one of the things from our perspective that we've been counting on, we've been kind of held back by our node implementation using Flatcar right now, because that can be kind of slow to become ready. But in terms of cost savings and cluster optimization, after playing with Karpenter a bunch, the key to me, one of the key aspects of it is just speed. How fast can I get nodes, and how fast are those ready? Because if we can get to a 30-second, node ready time provisioning and ready to take pods, that means we get rid of over provisioners, right? That means we can really crank up, node consolidation as much as our tenants can tolerate being disrupted, and start having conversations with them about improve your scaling speed and improve your toleration for chaos, and we can get your bills down. All right, so that's just my final little rant there on being performant.
Yeah. No, I think that's a great concern to bring up. And like now we're even like subdividing the performance, because I think of like different things when I think about this. And I think like you're absolutely right. Like right now, especially Carpenter AWS does a great job of making it from like when it decides it wants to add a node to actually adding a node to the cluster. It's very fast about that, right? And that's like that's something that people really like. And I think that's a great pressure for us to take back to the cluster API community as well, to say, hey, look, when I increase the replica count on a machine deployment, why am I waiting 10 minutes for a new node to arrive, right? How do we
Yes.
bring down that time? And that's where it's going to put the pressure back. It's not necessarily that Carpenter on cluster API is slow to make a decision. It's still making a decision in a very fast time. But now we're waiting for that cluster API. Like I've increased the replica count, and now I have to wait for that node to arrive. And that's where cluster API could do better, right? We could say, okay, how can cluster API get better at doing these things? And I think that's a difficult question to answer, but a great concern to bring up, Jeremy. Thank you. Okay, well, nothing else for me. If none of y'all have anything, we could take 5 minutes back here and get on with our Wednesdays. So going once, going twice. All right, sold. Everybody have a good day, and yeah, we'll see you next time.
Cool. Have a good
Thanks.
one.